Hello everyone. Today I'm going to show you something really interesting. We are going to break down Apple's famous clock app timer and reveal that it's not probably using some sort of magical timing mechanism for millisecond precision. In fact, I'll show you how to build a similar stopwatch experience in SwiftUI using TimelineView and TimelineSchedule. Let's get started. So I have the simulator here with the timer and the start and stop button. So if I hit the start button, as you can see, the timer starts running with also showing the milliseconds on the right side. So we will see now how we can implement this view. It's pretty simple, and I will walk you through all the components needed for this. So I can also stop here to make it stop. Okay, let's get started with the code. So the main API that makes this possible is the timeline view. Timeline view is a view that updates its body periodically with a given schedule. So you just declare a timeline view and you inject the schedule that conforms to timeline schedule. And here in the closure, we provide our main view, as we would normally do. Okay, so this is just pretty simple. Like just timeline view will update itself periodically with the given schedule from the given date. So we need to check now how the schedule is implemented. So how do we configure this updating mechanism? So if we come down here, we will see the metrics timeline schedule, which is a struct that conforms to timeline schedule protocol. And we also give it a start date to let it know since when it needs to update itself. And we need to implement, like when we conform to this protocol, we need to implement this entries method to provide an any iterator ultimately. So in order to do that, we first going to create a schedule, which is base schedule, that is time of periodic timeline schedule. We give it a start date, which is our start date, and we provide the by parameter to tell the system how often we want to update the UI with the schedule. And while doing that, we check the mode. So we see if the mode is low frequency. If it's low frequency, we want to update it once per second. But otherwise, we want to update it 30 times per second, and we achieve that by dividing 1 by 30. So this low frequency might be something new for you. It's like it's about the system running kind of in a low frequency, like updating the timers and the UI in a low frequency mode. I don't know so much about it, but I know, for example, when you have a live activities view and in an iPhone Pro device where the iPhone is locked, you still see this screen and you still see the live activity in the kind of low frequency mode. And in those scenarios, if you would use this view in the live activity view, for example, it will update itself less frequently. So this doesn't matter for our use case because it's in our main application and we have our timer running all the time. So it probably will never be low frequency for us, but I just wanted to keep it here for your future reference. And then we call .entries on the schedule and from the start date with the given mode. And finally, we return the any iterator with type of date. And inside the closure, we call return base schedule.next to give the next element. Okay, so this is how the schedule is implemented, and this is how we achieve to update the UI every second 30 times. Cool. So now that we have our timeline view set up, we have our actual view, which is the elapsed time view with the H stack with start and stop buttons. So now elapsed time view is where we configure this text over here, like the minutes, seconds, and milliseconds. So let's take a look at it. The elapsed time view is actually pretty simple. It has the elapsed time parameter, and it has a private time formatter. And in its body, we have text with the NS number where we provide the elapsed time, and we use the current formatter to format the text. So let's take a look at this elapsed time formatter, which is more interesting to get this kind of look over here. So it's a class elapsed time formatter that conforms to the formatter, and then we override the string method here to provide our string for as a formatted string. So we first declare the components formatter, which is a type of date components formatter, and we want it to be a date components formatter with by allowing the units as minute and second. So we want to show the minutes and seconds here, and we also want to give the zero formatting behavior as .pat. So when it's like 1 minute, it will show as 01. and if it's 1 second, it's going to show as 0.1, and then we return this formatter, and then we're going to use it while we're providing the actual string from this formatter. And what we do is first we try to cast the value as time interval. And if that's fine, we start using our components formatter to get the formatted string. So we're going to call components formatted.string, and what we are going to get is actually this part of the text. So we're going to get the minutes, this dots, and the seconds. And now we're going to need to compute the truncating milliseconds value with the separator. And how we do it is we come here and then we call truncating remainder dividing by 1 on the time, then we multiply it by 100. So what happens here is, if in this very moment the current time elapsed is 50.5 seconds, when we call this method, we are going to get 0.5 seconds. And then since we want to show the 0.5 seconds as 50 milliseconds, we multiply it by 100. And then ultimately, we also get the this decimal separator from the current locale, and we just format a string where we provide the minutes, second separator, and the remainder milliseconds here, and we return it. And since this view is updating itself 30 times per second, every time we calculate the elapsed time in our body, which is looking at the start date and then providing the time interval since now. And then every time we know the current time interval that passed, and then that's how we elapsed time you can compute the truncating remainder with the current millisecond value as well. And here in the elapsed time here in our content view, we just called start date the time interval since now to get the time interval since the start date started with right now. And since the start date is in the past, it's going to be a negative value. That's why we need to negate it again to make it positive. And that's how it shows the value here. And yeah, I also implemented 2 simple buttons here with start and stop to set the start date as now or set it as nil to kind of make it stop. So yeah, that's how you can also implement these in your applications. One thing to keep in mind though, when you provide the timeline view here, it initializes the timeline view immediately. So it starts redrawing its body with the given schedule immediately. So if you don't need to actually have a timeline view because there is no timer running, I would recommend you not to use this timeline view directly. Only use it when there is an active timer running, so you don't waste any resources. Probably Apple has some optimizations with this API. Maybe it can detect that there is nothing changing in its body and it's not using so much resources, but still it's not good to just directly use the timeline view and redraw the UI unnecessarily. But for the sake of simplicity, I directly use it right away here. But yeah, for your applications, keep this in mind and provide a static view unless your timer is running. So yeah, that's it. How you can implement your own timers that is similar to Apple's Globe application, and you can show the millisecond precision here as well. Yeah, I hope you like this video, and let me know what you think about it, and I will see you next time.